Here's the second video for the AP Calculus AB sample test number 2. We're looking at multiple choice questions numbers 10 through 18. Remember, these are non-calculator. Yes, we can use calculator to check our answers, but we shouldn't be using them to solve it. Let's start with the first one, number 10. The 10's a little bit faded, but this is still number 10. Okay, we're looking at this prompt as it says, how many points on the interval does the instantaneous rate equal the average rate? Well, the instantaneous rate is f prime of x. The average rate is really f of b minus f of a over b minus a. Or just so we don't get confused, let's stop using b and a since there are a's in this problem. Let's think of this as like x1 and x2. This would be f of x2 minus f of x1 over x2 minus x1. Another way that you guys have probably seen that is the slope. This is really just slope. And that was y2 minus y1 over x2 minus x1. That's how you saw it when you first learned it in Algebra 1. Then we added function notation to it, and now we're looking at instantaneous rate of change rather than just average rate. But what we're really asking is, when are these two things equal to each other? Well, let's take a look at the pieces we have and start setting them up in a relationship that we can interpret. Well, f of x2 and f of x1. Our x2 and our x1 are right here. So that means e to the a squared is f of x2 minus e to the negative a quantity squared all over a minus negative a. I'm getting that from here and here. So I hope you guys see where these values are coming that I'm plugging in here. So if I were to simplify that, a minus negative a on the bottom, that's 2a. Simple enough. But on top, negative a squared is the same as a squared. So this is really e to the a squared minus e to the a squared. So these two terms here and here are the same. So that's just going to be 0 when I subtract those. So this equals 0. Then what I'm really asking is, when does the derivative, or the instantaneous rate, equal this value of 0? When does that equal the derivative? Let's figure out what the derivative actually comes out to be. We have e to the x squared. Well, we got to multiply this by 2x. Where am I getting that from? Because the derivative of e to the x, or e to the u, I should say, is really e to the u times u prime, or du, or whatever you want to say, du dx. This 2x is the derivative of x squared. So I'm going to use that. I'm going to ask, when does that equal this average value, which is 0? So we have 0 equals e to the x squared times 2x. Well, e to the x squared, this piece here, this is always positive. How do I know? Because e to any power is going to be positive. It might be really small, but it's always a positive number. So then I'm just asking, when does 2x equal 0? And that's when x equals 0. Does it happen any other time? No, not at all. So that means that this here only happens once, and it's when x equals 0. When x equals 0, the average rate of change will equal the instantaneous rate of change. Now, just to give you guys a little bit of a tip, this function would have looked kind of like a parabola, not really, but it would go up increasing on both sides. And if we're going from negative a to a, this has a even symmetry to it. So when we're looking at this graph, we're going to be at the same point on both sides. That means that the average rate of change, this blue horizontal line, the average change equals 0. When does that happen? Right here in the middle at 0. It only happens once. Our answer would be B. Let's keep on moving. Check number 11. Number 11 here, it says let the function be f of x equals x cubed. What are all values c that satisfy the conclusion of the mean value theorem on the closed interval -1 to 2? This is kind of weird. You know why? Because the mean value theorem is saying the same exact thing. It's saying when does the average rate equal the instantaneous rate? That's what we're being asked when we're talking about mean value theorem. That's what we actually used back here in number 10, was mean value theorem. So let's do that. The average rate is really f of b minus f of a over b minus a. And over here, this is f prime of x. We're going to go even more specific, and we're not just going to say any x, we're going to say f prime of some specific x. Well, let's call that c. Then we need to figure out what is that value c. That's what this c is right here. Well, f of b minus f of a. Well, here's a and b. I need to figure out what f of b and f of a are. Well, that's going to be 2 cubed minus -1 cubed all over 2 minus -1 equals. We've got to figure out what that c is. Well, we know that f prime of x is equal to 3x squared. So then f prime of c is equal to 3 times c squared. So this is really 3c squared. Now we've got to solve. So let's simplify this fraction. We got 8 minus -1 over 3 equals 3c squared. If I were to simplify that a little bit more, that would give me 9 over 3 equals 3c squared. So 9 equals 9c squared. 1 equals c squared. C equals 1, but it's actually plus or minus 1. Why? Because -1 squared equals 1, and +1 squared also equals 1. So both of those would be correct answers. So up here, our choice would be D. And if you still need to write it down. Next, scroll up to this prompt here. Okay, so a few things going on. First, we have the word region in here. Whenever we're talking about region, that probably means something to do with an integral. We even have boundaries. We know we're going from 2 to k. Well, k isn't really specified, but it's still going to be used somehow. We need to actually solve for k. Well, we know that the area is natural log of 4. That means that this area of the function is equal to natural log of 4. Well, we actually know what that function is. They gave it to us right here. And we know that we're going from 2 to k of 1 over x dx. And we're going to have that equal to natural log of 4. Well, I know that the derivative, or the antiderivative of 1 over x dx, or just dx over x, either way, is natural log of x. Now we're in the positives here, so we don't really need to worry about absolute value. Just natural log of x from 2 to k, and that's still equal to natural log of 4. Well, if I were to evaluate this, top minus bottom, f of b minus f of a, just like we've done with all the other ones, that would give me natural log of k minus natural log of 2. That's going to be equal to natural log of 4. As I'm looking at this, I notice that I have a difference of logs, meaning I'm subtracting two terms with logs, and they have the same base. They're both a natural log. That means I can combine that into one term, a quotient of these two terms. So it's going to be natural log of k over 2 equals natural log of 4. Let's scroll down a little bit here, give ourselves some more space. If I raise both sides with the base e, that's going to give me k over 2 equals 4, or just k equals 8. It's that simple. The answer is B. This is one of those easy, quick problems. If you recognized that they gave you the area, and all you had to do is work backwards and find k. Pretty straightforward. As I'm looking at this, I notice that I have x's and y's mixed all around, and I need to find a derivative. That tells me I need to use implicit differentiation. So I have x plus y equals xy. I need to find the derivative. So I'm just going to take the derivative of everything with respect to x. Derivative of x with respect to x is just 1. The derivative of y with respect to x is 1. But it's dy dx. It has a chain rule action going on with it. And over here we have a product rule, x times y. Well, I know that I'm going to have the derivative of the first times the second. So the derivative of x with respect to x is 1 times y plus the derivative of the second, which is 1 dy dx times x. If I were to rewrite this a little more simply, I'd have 1 plus dy dx equals y plus x times dy dx. So what I want to do is I want to group those dy dx's together. Doesn't really matter what side we go on. Let's go and move them over here to the left. That means I'd have dy dx plus, or minus, pardon me, dy dx minus x dy dx equals y minus 1. That's what I'm doing here is I'm taking this 1 and moving it back over to the other side, from the left over to the right. And I'm taking this x dy dx and moving it over here with the other dy dx. Once I'm at this point, I can do some factoring and dividing. I know that I have dy dx in common to both of those, so I factor it out. That'll give me 1 minus x over here, and then y minus 1 on the right. To get that dy dx by itself, I'm going to divide both sides by 1 minus x. So I have y minus 1 over 1 minus x. Let's go back and see what our answers have for us. Remember, we have y minus 1 over 1 minus x. Well, this is kind of interesting because b is kind of close, but not really. It has the x and the y first and the negative 1 second. I have that y minus 1, but that bottom doesn't match. This second one, it's almost like both top and bottom are out of order. And what we need to realize is that if we multiplied the top and bottom by negative 1, that would flip this negative sign around. So it would be negative y plus 1 over negative 1 plus x. Or in other words, 1 minus y over x minus 1. So these two pieces are actually equal. Why can I do that? Because you can multiply the top and the bottom by a negative. So the answer is C. For this next prompt, it's saying that f and g are continuous and differentiable the entire time. Why would they say that? Here we go. These are differentiable functions. Well, they're trying to tell us that we're allowed to take the integral of them, and that we're allowed to take the integral of the composition of them. So when we have f of g of x, we can take the derivative or the integral of that as well. What we want to notice is this last term that we have here that says f of g of 4 minus f of g of 2. That means that we have some integral of something equals f of g of x evaluated from 2 to 4. That's where this came from. So that means this right here is probably going to be 2 to 4. That doesn't really help me because all of those have that. But then what I want to try and think about is if I take the derivative of this f of g of x, that should give me what I started with. Because what I'm doing here when I take the integral, this is the antiderivative. So if I took the derivative, that would put me back into the integral because I need to know what is this piece. Well, that's just a chain rule. It's the classic form of the chain rule. If I have f of g of x, and I'm taking the derivative of that, I'm going to take derivative of the outside, which is f prime, leave the inside alone, and then multiply by the derivative of the inside, g prime of x. Then I have the inside left alone. So that's what I'm looking for. That's what I want to be in that box. Well, the only one that matches then is D right here. It's got g prime or g of x left alone on the inside, then the derivative of the inside last here, and it has the f prime as well. This next one, we're talking about velocity. This says it's moving along the y-axis. Doesn't really matter whether it says y or x. One axis is the movement, the other one is just time. So here's our y-axis, here's time. What do I mean by that? That means that this one is time t and this is y. It says that velocity is 8 minus 2t, and the particle is moving upwards until it reaches the origin. So it actually comes up to the origin and then goes back down. So it's coming up, hits the origin, and then goes back down. What that tells me is that when t equals 0, that also means that the velocity equals 0 and the position, which in this case, if we were to just call it s of t, that also equals 0. Let's go ahead and see what we can do looking at this information here. We know that the antiderivative of velocity is equal to position plus some constant. Actually, it's just equal to position. Oops, we didn't mean to get that. We want the eraser. So let's see what the antiderivative of this piece here would be. We have 8 minus 2t dt. The antiderivative of 8 is 8t. Minus 2t becomes minus t squared. And then we have plus a constant. So this equals our position. But we also know that our position is 0 when t equals 0. So I'm going to replace these t's with zeros. And that's also going to equal 0 here. So that just means 0 plus c equals 0. c equals 0. So our constant is really 0. That means our function is just 8t minus t squared. The answer would have been E. Number 16, this is a substitution. All year long I've done substitutions. I haven't actually done a lot of substitutions where we work with the limits, but it's pretty much the same thing. We know that u equals square root of x minus 1. That means that this piece here is going to become u. So in our new integral, we're going to have a u on top. Now, the catch then is looking at this dx and the du and also this x on the bottom. I got arrows all over the place. I need to erase some of these. So the pieces that we don't really know too much about is this x, the dx here, and this x. So let's start by doing some substitutions. Okay, and we made the one substitution, but it's probably going to help us a little bit if we rewrite this piece here, if we solve this for x. If I were to solve both sides for x, that means I would have u squared equals x minus 1, so u squared plus 1 equals x. If I take both sides the derivative of that, that means that 2u du equals dx. So this dx right here is 2u du. So I'm going to have a 2u du there. And x in the bottom is equal to u squared plus 1. Now the limits are pretty similar all the way through. The only things that we need to check is it e or is it a? It's one of those because they're both pretty similar. Well, I know that u equals the radical x minus 1. So if I start with a 5, then u on top is going to be the radical of 5 minus 1, which is square root of 4 or 2. So the top should be 2, not 5. So that means that E is the answer. So this was a lot of translation. I need to figure out what was this dx, what was this x, excuse me, and what were the limits as well. You got to translate every piece, not just part of it. What are all values of x for which the function is increasing? Whenever you hear the words asking you when is it increasing, decreasing, max, min, point of inflection, all that stuff, that's curve analysis interpretation. We need to know the derivatives in order to figure that out. Let's look at the first derivative. F prime of x, it's a polynomial, so this should be pretty straightforward. It's going to be 3x squared plus 12x plus 9. If I were to factor that, I could factor out a 3. I'd be left with x squared plus 4x plus 3. I could factor that even further. So 3 times x plus 3, x plus 1. Why do I care? Because I'm looking for those critical points. And those critical points on polynomials only happen when the derivative equals 0. So if I set all these terms equal to 0, the only things I'm going to come out with for x is negative 3 and negative 1. So those are my benchmarks. Those are my checkpoints that I need to use in order to figure out where is it going up, down, flatten out, and all of the in-between. So let's make a little chart here. Let's start with x, look at f prime of x, and then ask ourselves what's the original function doing there. So let's change to gray like we did last time, get some horizontal lines in here. We know that we need to look at negative 3 and negative 1 and in between. So that means we're going to need 5 boxes. So I'm looking at, let's start writing this in black. We're looking at negative 3 and negative 1. And now we want in between. So what's in between those? How about negative 2? What's below them? How about negative 4? And above, let's do 0. Okay, we know that at these 2 points it's going to be 0 and 0, so it's flat and flat. So it's not increasing on either of those. But it might be increasing here before, in between, or after, or some combination of those. Let's find out. So if I were to plug in negative 4 into the derivative, that would give me a negative here for this first term, and a negative as well for the second term. And a negative times a negative is a positive. That means it's increasing. I could already start to look at some of my answers here. I know that A is potentially correct. B is for sure wrong because it doesn't include negative infinity up until 3, which is that interval there. Negative 1 to infinity only is wrong because it needs to include this area in the beginning that we were just looking at. So it's either A, D, or E. I don't think it's E because our benchmark is at negative 1. So it's either negative infinity to negative 3 only or negative infinity to negative 3 and negative 1 to infinity. Let's double check. That means that in between here this must be decreasing, but just to make sure, if I plug in negative 2, I get a positive for the first term, a negative for the second. That makes it negative and decreasing here. Now when I plug in 0, that's going to give me a negative, or not negative, a positive and positive, which makes that positive, makes the function increasing. So it's increasing here at the beginning and here at the end. That means that D would have been our answer. Last part, for part 2 here, pretty straightforward problem. Again, we have a constant, and we have a setup, and we have our final answer in the end. We just got to fill in the middle. So what I'm going to do is I'm going to take the antiderivative here of this piece. So I know that 2x cubed now becomes 2x to the 4th over 4. Kx squared is going to become kx cubed over 3. And 2k is going to become 2kx. We're going to evaluate that from 0 to 2, and then we're going to know that that equals to 12. And we're going to have to solve that equation, find out what k is. I noticed that with the 0, if I were to plug the 0 into each of these terms, that would just be 0. So the bottom's just going to be minus 0. What I'm really concerned with then is the top. 2 times x to the 4th. Well, that's 2 times 2 to the 4th. All divided by 4. Minus k times 2 to the 3rd over 3. Plus 2k times 2. Let's simplify this. 2 to the 4th is 16. So we got 2 times 16 divided by 4. That's going to reduce to 4 over 1. Minus 8 over 3 times k plus 4 times k. And we know, of course, that this is still equal to 12. If I were to simplify this side even more, I have 8 minus 8/3 k plus 4k equals 12. Combining some like terms and moving numbers over here, we're going to move the 8 over. That gives us 4 on the right side. And we're going to combine negative 8/3 and 4. Well, 4 is really 12/3. So negative 8/3 plus 12/3 is really 4/3 k equals 4. So to get that k by itself, I got to multiply both sides by 3/4. Make a 1 with the left. On the right, we make a 3. So k equals 3. Is that the question it's asking? K must be 3. E. That's the end of part 2. We'll be looking at part 3, which is the last part of the non-calculator.